Okay, let's continue, and in this lecture we check the performance of these instructions we wrote before. For this purpose we press emulate on the code window, and now we see an emulator window as well, and we can proceed step by step, like pressing single step, and we see what each instruction does. Oh, have this one here. Okay, so after doing the first line, we have a FF value, hexadecimal value in bigs, which is corresponds to decimal value 255. So, yeah, you will have a lecture on how to transform decimals to hexadecimals and vice versa. Okay, going next, we move the same value to register AX. Now we simply did XOR, which led us to the zeros in AX register. Now we will put value of 5 to the stack. Yeah, we will see this. Yeah, see now? Stack pointer will go down, and we will see value 5 in it. Yeah. Now we make bx equal to 0, and now we assign ax with the value in the stack. So we extract the value to which the stack pointer is pointing to. Yeah. And stack pointer is FFFC, so this is with current cell, and the value of 5 will be assigned to AX. Here it is. Yeah. Next we add AX and BX. It was 0 plus 5, yeah, so AX is equal to 5. And now we do adjustment after addition. Nothing happens as a lower nibble of AL is less than 9. So, and now we do multiplication, and yeah, it was 0 with 5 is equal to 0. Okay, I will reload it again, and now check again the steps. Okay, it's 5, and then bx is 0. Okay, so we have a result, zeros in all registers. Okay, just this was a small example of performance of these instructions. Okay, check it out, and see you in the next lecture.